Hello, everyone. Welcome to, Global Hack Week Day 1, first of all, but welcome to the Everything You Need to Know About REST APIs workshop. My name is Joe Nash, and I'm a developer educator at Twilio, and I will be running through a bunch of topics related to REST APIs, and in general, getting data and accessing functionality from your programs over the internet today. To kick us off, let's talk a little bit about Twilio and Twilio Quest, and talk about the challenges that Twilio has ready for you this week for Global Hack Week, and then talk about how REST APIs are related to that and how they will help you in the rest of your developer journey. Rosendo, throw me the screen. There we go. Awesome. So, as I mentioned, I work at a company called Twilio. Twilio, for those of you who are not aware, is a company that provides APIs to help you add communications to your applications so you can do things like there we go. You can do things like make websites that make your phone ring, or send SMS and WhatsApp messages from your applications. You can build chatbots, you can build video applications. If it involves communications in some way, whether that be by a mobile telephone, the internet, or things like email, you can probably find a way to do it with Twilio. And in particular, I work on a educational programming game that is free to play called Twilio Quest, which helps you learn to code and learn software-related concepts like open source, like GitHub, and like REST APIs, all from a cozy 16-bit inspired game. Part of the weekly challenges this week will involve playing Twilio Quest if you want to take part, but we have other challenges as well, and you can find all those challenges on the Global Hack Week website alongside the other challenges. So today on day 1, it is getting ready to hack with Twilio, which is getting your Twilio account set up and unlocking your free credit and account upgrade, which you can find with the code here. There is also the Twilio Quest challenge, which is up here. So the Twilio Quest challenge, we will be awarding prizes to folks who play and earn the most points in Twilio Quest. There you go, chat. There's the link to the challenges website. But this is the website you'll be coming back to throughout the week. This is where all of Global Hack Week happens. So that is the challenges for today. There will be new Twilio challenges up every single day. You can get a spoiler of those challenges using the guide that is linked. When you click through for the guide, you will come to our handy this is the wrong guide. Rosendo, whilst you're watching the stream, could you update the links to this one? This guide that I've just put in the chat, which will be in the website, maybe I'll just push that readme to this one just to solve the problem, is a walkthrough tutorial of everything you need to participate in Global Hack Week with Twilio this week. This is a tutorial to complete all of the daily challenges. So you can see here we have a section for every day. It will walk you through everything you need to do to complete all 7 of the Twilio daily challenges, as well as you getting set up for the Twilio Quest challenge. Inside this link, you will find the join code for the Twilio Quest operation, so you can start earning XP and have a chance of winning those prizes, as well as instructions to upgrade your Twilio account, to start making HTTP requests using popular tools like curl, and to put into practice the things that you're going to learn in this workshop here today. Thank you, Emily, for putting that on the screen. We will get that link updated in the challenge thing. But for now, if you interact with anyone who's doing the Twilio challenges, tell them to ignore that link and use the one on the screen. Today, we are going to be talking about REST APIs, and to do that, we're going to have to talk about how the internet works. But before we get into that, let's talk a little bit about why the topic that we're addressing today is important. You are here participating in the Hack Week, so I imagine you're interested in a software career. Someone has posted a YouTube video. I'm not going to watch that during the stream, but thank you for sharing. Seems sus, but that's okay. As someone pretty engaging in a software career, you will likely be creating applications which access data over the internet in some way, shape, or form. And as those applications access the internet, they might want to access data from services such as things like GitHub and Twitter to use in your own application. They may also provide their own data over the internet to other applications or to user interfaces. And finally, You may want to access functionality provided by other services. For example, you might want your application to create a video chat or to send an SMS message using Twilio, and that requires utilizing requests to other services over the internet. And those services that you access from your applications are called APIs, and they are a very particular kind of API, which is a remote web API. But there are other types of APIs, and that's where we're going to start today, talking about what APIs are and how APIs work. Did anyone in the chat want to kick us off with the question, what is an API? Can anyone tell me what an API is? Every time I do this workshop at Global Hack Week, I get a new awesome answer to this question, so I'm very excited to see what this chat brings. Anyone in chat want to take a stab at this question? What is an API? Give it a couple of seconds, and then I'll jump in with the spoilers. An application programming interface. Thank you, Mr. Beast. That is exactly it. Oh, who I imagine it's not the real Mr. Beast, but that'd be sick. So we have an application programming interface. What does application programming interface mean? Hey, Joshua, thanks for joining us. What does application programming interface even mean? Well, one possible definition, or one possible thing that could mean, is, as Kaushik says, code talking to another code, or as Vanny says, a way to get data from the source through a link. Siddharth gives another great answer. It's a way for two or more computer programs to communicate. These are all great and accurate answers. They are not the total answer. What each of you have described is a certain type of API, and there are many types of APIs. Let's talk about the most general case. Let's talk about the most general case, i.e. the most what's the most encompassing umbrella definition of an API? Well, let's imagine, let's go for a metaphor that actually Global Hack Week gave me during Global Hack Week Init, I think, which is a metaphor that I really like to explain APIs. So let's imagine that, things are scrolling. Let's imagine that you are at a restaurant. Let's draw your little table. Here you are, here's your restaurant table, and you are at this restaurant, and there you go, you're sitting here, and you're chilling in this restaurant, and you've got yourself a menu. Here we go, let's give you a little menu. You've got yourself a menu to browse at the restaurant, to browse your food. And you're looking through this menu, and it's got lots of options, lots of really exciting meals, lots of really complicated meals, and they all look fantastic. And you're sitting there browsing that menu, and then the waiter comes along, and the waiter asks you what it is you would like. And they... Ooh, hello. Ooh, no, why are you doing that? The waiter comes along and asks you what it is you would like. And when you answer the waiter, what the waiter's going to do is the waiter is going to take that order, and they are going to take it over to the kitchen. And in the kitchen, some magic is going to happen. The chefs are going to do their thing, and the food is going to come out from the kitchen, and it's going to come back to you. You don't have to know what's happened in the kitchen. You don't have to know anything about how the food is made, what the chefs have done, how it's prepared. But what has happened here is that you have been given a menu and a waiter who has taken your order from the menu and has taken it to the kitchen and communicated your request to the kitchen, and then the magic has happened and you have been given what you have ordered. This is an example of an interface that allows you to request something and get it back without having to know the details. This, in other words, is a great example of an API. Why is this an API? Well, the menu is acting as your interface. Well, the menu and the waiter. The menu and waiter are acting as your interface. You've been able to request functionality, and that functionality has been provided without you knowing the details. That is, broadly speaking, how APIs work and what makes an API unique. The APIs that you folks have been giving examples of in the chat are particular to web APIs, which make this work over the internet. But APIs can be a lot more basic than that. If you think about your programs, say for example, you have a JavaScript program, and in that JavaScript program you were to import, I don't know, a library for making shapes, and maybe it's just called shapes, right? So imagine a library exists, and it's just called shapes. And this library allows you to make new shapes. Well, you might create a circle using that library by accessing a constructor in that library that makes circles, right? That might be, how this library works. This library has a bunch of functions, a bunch of constructors, a bunch of classes for creating shapes. Maybe it's as simple as actually just doing shapes.circle, right? It's just a function where you give it the diameter of the circle and it makes that circle. This is an example of an API. It is an interface that has been created by a programmer for another application to use, where I, as the programmer who's using it, don't need to know any of the details. I don't need to know how this circle is created or what happens inside. I'm just given a function name and some parameters to give it, and the thing I want is produced. Harsh says application is food. The application in this case, I guess, would be the kitchen. The application is the kitchen, and the things the application shows or produces to the user would be food. Dead Nuggy said that makes so much sense. Great, I'm really glad. I can take no credit for it. As I said, Global Hack Week in it, I can't remember who, but someone in the chat gave the restaurant example when I asked that question in September, and I was blown away. I thought the waiter example was so good, so I have shamelessly stolen it. So thank you, Global Hack Week. So this in itself is also an API. But here we are today to talk about another type of API, which is web APIs. This is an API within the context of a program on your computer, but web APIs are another category of APIs where the method of making requests and exchanging data is defined by internet protocols. APIs where the method of requesting and exchanging data is defined by internet protocols. And what do we mean by internet protocols? Well, someone actually defined internet protocols in the chat earlier as the definition of an API, but a protocol is a set of rules that we use to communicate. And that allows two figures who don't necessarily know each other to communicate consistently. And the type of protocol, one of the protocols that we use most in the internet is HTTP. You have probably all heard of HTTP. At the very least, you will have seen it whenever you type a URL in your browser. It's always here at the front. And what HTTP means is Hypertext Transfer Protocol. And it is the protocol that enables the exchange of data throughout the web. It's one of the most common ones, and it enables us to make requests and to receive responses. Bring Me Thanos says, am I late? You are not super late, you're only a couple of minutes late. Just to bring you up to speed, we're talking about APIs today, and we've just started to talk about APIs that take place over the web. An API is an application programming interface that enables you to make use of the functionality within a program, whatever that may be. It's commonly getting data, but it's also sometimes making things happen. And we are going to be talking about APIs that work over the internet using protocols such as HTTP, the Hypertext Transfer Protocol. And that's where we're at so far. Chat, did I capture anything? Is there anything I missed in that summary? Let me know. So, Hypertext Transfer Protocol lets us communicate and request things around the internet. And there are two sides to the Hypertext Transfer Protocol. There are clients and there are servers. Clients are the ones that make requests. And clients include things like your web browser. Your web browser is a HTTP client, but it also includes tools such as curl, and it can include HTTP clients in software. So you have HTTP clients in your favorite programming language, for example. Servers handle those requests. So servers receive requests and they decide what to do with it. So a web application, a web application that you build during a hack day might be a HTTP server. For example, you might use something like Express, Flask, or Sinatra. Those are all HTTP servers in Node.js, Python, and Ruby. You might have also heard of things like Apache or Nginx. These are all HTTP servers, and every application on the internet that powers a website or that powers a web API is a HTTP server. Now, when we make requests, we are asking for data or providing data, asking for or providing data to a URL. And along with that, we give some other really important information. We provide things called headers, which is information the server needs to understand the request. And we also provide what's called a HTTP method or a verb. And this is the type of request we are making. Let's see that in action. I'm glad you enjoyed that example, Dead Nuggy. Let's see that in action. Let's go over to google.com. So in my browser, I'm going to type google.com and I'm going to press enter. And what happens is then the website for Google fills my screen. But a lot of stuff has happened in the meantime, and we can actually see that happen by opening up our browser's developer tools. So you can right click and go to inspect, and then you get the developer tools. You may have seen these if you've done any web development. There's a bunch of useful stuff here. I can see all the HTML of the website. I can have a JavaScript console, but I can also go to this network tab. And this network tab shows the HTTP requests that are going back and forth when I use this website. So if I now press refresh and ask for the website again, we'll see a whole bunch of stuff happen. Look at all that, loads of requests. And if I scroll to the very first request, what we see here is that we have a status code, a method, a domain, and some other info like the type and the amount of data transferred. This is the HTTP request that was sent when I first typed in google.com and pressed enter. Because HTTP is used to actually get websites. So HTTP is a method for exchanging data over the internet, and websites themselves, the HTML, the CSS, and the JavaScript that makes up a web page is an example of the data that can be transferred via HTTP. And my browser, as I said, is a HTTP client, which means it makes HTTP requests. And this is one of those HTTP methods I said. So every HTTP request has a type of request, and there's some really common types, and we call those methods. And this request, the request for just asking for data, for just asking to receive some data, is called a GET request. You get it? You're asking to get something from a URL. So I've gone to google.com and I've sent a GET request saying, give me google.com, give me the website. And we can see here we have a status code of 200. Status codes indicate what has happened with your request. They indicate whether it's been successful, whether there's been an error. 200 is the code that means okay. It means everything has gone as expected. Your request has been fulfilled. Here is your data. So we can see that I've asked google.com for that information, and I've got that information back. And we can see that there's 45 kilobytes worth of data here. Excuse the comma, I'm in the Netherlands, which uses commas for decimal points, just barbaric. But it is 45 kilobytes, not 4,553. So that is the most basic type of HTTP request. Let's start talking about these methods. So we have these HTTP methods, or verbs. They can be called either thing. And one of them is GET, which is a request for data from a HTTP server. Another type of really common request is POST, where you provide data to a HTTP server. And if you were paying attention, you might have seen some posts here as well. And this is where things get a little bit weird, a little bit funny. You'll see that these posts don't have a status code. They have just a big angry red X. This is because these have been blocked by my ad blocker, because these aren't post requests made by me. These are post requests made by scripts within the Google page to try to send my information to Google's ad servers, and so my ad blocker has blocked those requests. But this does give us a really handy example of what a post request is and the kind of ways that post requests are used. Post requests are for when you want to send information to a website. So for example, if you're logging in and you're providing your username and password, that is information you're sending to the website, and so it will be a post request. If you're making a post on Twitter or Facebook or Instagram, you are sending your post to that website, and so it will make a post request. And in this case, this is Google trying to send my information to its ad servers so that it can use that to show me relevant ads later, and that is also a post request. Post requests Really important thing to know, although it is us as the HTTP client sending data to the server, we still expect data back from the server. We still expect the server to return something as a result of getting that information. Again, for example, if you were to log into a website, once you've entered your username and password and you've clicked login, you're sending a post request, but you would still like the website to then like show you logged in, right? So you're still receiving information. As an example of that, here is me typing in Global Hack Week into Google, and this is a query that I'm making, so this is going to be a post request. And there's actually a lie. It's a get request by query parameters, but you can imagine it's a post request. And we still get, a new web page back with the information that we've asked for. So post requests are used to send information. There's a couple of other HTTP methods that are common, but you won't see as often. There, for example, methods to update information. There are two of these, put and patch. And there is also delete to remove information from a HTTP server. Okay. So that is the basic of HTTP methods and verbs. Before we put a pin in this section, let's quickly talk about HTTP response codes. So we saw one response code already. We saw 200 OK. Why is OK the number 200? Well, HTTP response codes are broken up into groups of 100, and they start at 100 and go all the way through to 599. And every block of 100 indicates a different grouping of messages. So all of these success messages are in the range 200 to 299. And there's different types of successes. 200 is the most basic, and that just means 200 OK. There are also redirection messages, which is when you ask for something at a web address and it's not actually at that place and it's been moved somewhere else, and that's in the range 300 to 399. Then client errors, and there are server errors. So we spoke a bit about the difference between client and server. Clients are sending the requests, and servers are receiving the requests. And each of those things could cause an error. So 400 is for errors from the client, and 500 is for errors from the server. There's some really interesting and unexpected things here, and I find that people quite often get confused about why a client error is a client error. And the most common place for that is 404. You have almost definitely heard of 404 not found. That's probably something that you see on websites all the time. The reason, what you're actually seeing there is a HTTP error 404, which means the document that's been requested hasn't been found. That is a client error. For example, if I were to go to http twilio.com, and I were to go to totally made up web page, just a part of Twilio that I've made up, you see we get 404 not found. If I open up my inspector and go look at the network tab and give it a refresh, we get 404. Because this web page, totally made up web page, does not exist on twilio.com. That is a client error because I, as the client, I, as the web browser, have requested information that does not exist. So that is my fault. It is not the server's fault for not having that information. You will see a server error, something in the 500 to 599 range. A server error, something in the 500 to 599 range, when something has gone wrong whilst the server is trying to process your request. So imagine you go to log into a website and the server crashes. That will be a 500 error, right? There are some interesting and tricky things around client errors. So some of the client errors that you'll regularly encounter will be about authorization. So there are two types of client errors related to authorization, which is 401 unauthorized and 403 forbidden. 401 unauthorized is when you try to request access to data and you are not logged in. So you do not, that data requires certain user permissions, and you are not logged in at all, so the server doesn't know if you're allowed to access that data. 403 forbidden is slightly different. It's when you try to request information and you are logged in, but you don't have access to that information. There is something kind of funny that happens with these, which is that although these are things defined by the HTTP protocol, a set of rules we use to communicate, these are not always used how you'd expect. And a really good example of that is on GitHub, right? So let's go to GitHub and let's go to my GitHub repositories. So this is my GitHub repositories, and let's go to this repo. So this repository here is a private repository. It's a repository I made. It's private on my account. Only I can see it, right? only you have to be logged in to my GitHub account to see this repository. So chat, if I were to go to a new tab where I'm not logged in, to try to go to this repository. Oh no, I've given spoilers. Hopefully you didn't see that. If I were to go to a new tab where I'm not logged in to try and go to this repository, what would you expect to happen? What HTTP error code would you expect us to get when I go to a private repository on GitHub when I am not logged into GitHub? Does anyone want to take a guess what HTTP code we should see in that case? You can take a guess while I sip my coffee. So Pranav says 404. That might be because you just saw it, for Pranav. Ah, you're all no fun. Okay, it is 404, and this is actually kind of incorrect. It shouldn't be 404. According to the HTTP specification, I am trying to access a web page that I do not have the permissions to access while I am not logged in. So it should, in fact, be a HTTP error 401 unauthorized. If I were to log into a different account and try and access this website, this repository, it should then be 403, forbidden, because I'm logged in but I don't have permission. The reason it's a 404 is a security one. Because the interesting thing about 401 and 403 is they say, hey, you don't have access to this thing. And in doing so, they confirm that the thing exists, which is dangerous. If you came up to me on the street and you were trying to steal my money and you said to me, give me the $1,000 in your wallet, and I said, I'm not giving you the $1,000 in my wallet, I'm confirming to you that I have $1,000 to steal, right? Whereas if you come up to me in the street and said, give me the $1,000 in your wallet, and I just said, I don't know what you're talking about, you might think that I'm not worth robbing, that I don't have $1,000. And that's what GitHub is doing here. I don't have access to this material. I don't have access to this repository because I'm not logged in. And GitHub is not confirming that it exists. And this is a really important point because, as we spoke about earlier, HTTP is a protocol that sets the rules for communications between a client and a server. But those rules are not always necessarily strictly followed according to the spec, for reasons like security, or just because really at the end of the day it's up to the coder who builds the server and builds the client to implement those rules, and we sometimes make mistakes as well. So there's an important thing to keep in mind as you interact with these services, that sometimes, although you might know the HTTP response you should be getting, it won't always necessarily perform as you expect. So that's the response codes covered. We now kind of know the basics of HTTP. Does everyone feel okay? Does everyone feel like they understand HTTP and how it works in regards to the internet? Give me thumbs up in chat. Or like caffeinate. You bunch of cheaters. I see all of you putting 404. None of you had a clue. Perfect. I'm getting thumbs up. Wonderful. Okay, so let's move on to REST APIs, the topic of the workshop. We're 30 minutes in and we're finally talking about the thing that's in the title. Like any good workshop, we leave the best until last. So REST APIs are a way of using APIs over the internet that provide structure to the way we request data, right? So this is the most important thing about REST APIs, which is that they are just a set of guidelines that help developers use and create APIs. And I really want to make this super clear because people see REST, and REST is an acronym, and they think it's, you know, a really clearly defined thing. They think it's, you know, like HTTP, a set of rules that a big body has written down and put in a specification. And actually, REST is a lot more wibbly wobbly than that. It was originally an academic dissertation that the industry then got hold of, and there's been a lot of best practice built around that. But unlike HTTP, which is like a specified set of rules that you can go and read on the internet, REST is not that. REST is just a set of guidelines that help us do a certain category of thing a little bit better. So just want to make sure that's really clear, because that's one of the first things that people get really confused about when they see REST. But what it is a set of stuff to make it easier for us to use APIs. And why is that important? Well, APIs let us use other programs from our programs. And part of doing that is reading and understanding documentation. And if all APIs work kind of the same, then it's easier for us to use them. And REST ensures that APIs do work kind of the same way. Hey, 404 not found. You've joined in just in time to miss all of the bit about 404 not found. But I'm glad we found you. So let's go see an example of a REST API, which is the GitHub API. So I'm going to go to first of all, I'm going to go to GitHub API docs. So I'm going to go to the GitHub API documentation, and I will post this link if you want to follow along. And we're going to go look at a particular API, which is the users API. So I'm going to scroll down here and go to users. And I'm going to scroll down to the get a user endpoint. So this is a endpoint on an API. This is API documentation. All API documentation looks broadly similar. And we'll explain kind of why that is in a bit. But first of all, let's play with this API. So this API is available for GET requests at api.github.com/users/username. So if I were to, for example, open up my browser tab and go to api.github.com/users/Joe Nash, this will send a HTTP GET request to the GitHub API to get the data associated with Joe Nash, the GitHub user. Now, normally when we send a GET request in our browser, we are requesting HTML, CSS, and JavaScript as the data that we're exchanging. But in this case, we are going to be requesting JSON, which stands for JavaScript Object Notation and is a common data exchange format on the internet. And the reason we get this JSON is because as an API, this isn't intended to be used from a client like our browser. It's intended to be used from our own computer program. It's intended to be used from another program that is trying to make use of GitHub data. And so it provides just raw data, not HTML. Now, our browser does understand JSON, and so it's made this nice and pretty for us. If you haven't seen JSON before, it's a key value data structure. So you have the name of the property and then a value for that property. So we've got login, and we can see here that login is Joe Nash. And so it's given me just a big blob of data that I can use in my programs. For example, I can start up a terminal, and I can use a terminal program called curl to make HTTP requests. So I can go curl https api.github.com/users/Joe Nash, and I can pipe that into a program called JQ to make it pretty, hit enter on that, and I get that data back. And now that I've got that data here, I can do all kinds of fun things with it, right? Like because I'm in a Linux shell, I can start to use that in other ways. So I can pipe that into a file called joenash.txt, and then I can look at that file, and I can start to build programs and scripts using this API. And that's the purpose of APIs. What's not super obvious is that the way this API works is the way that every other REST API works, and that is by two sets of things: resources and HTTP methods. So let's take a look back at the documentation. Are documentation's APIs for humans? Oh, what a fascinating question. Is documentation an API for humans? I would say no. Because it might be data, but it's not necessarily functionality, right? Like, me reading the documentation doesn't make another human do something, right? Language is probably the API for humans. I think. I don't know. This isn't philosophy stream. Okay, so anyway, back to what makes this the REST API. So I've got this long list of things on the left here, right? These are all of the different things I can do with the GitHub API. And it's things like, accessing users, accessing commits, accessing repositories. It's all of the objects, all of the different categories of data that are available on GitHub. It's all of the different kind of objects and things that are available on GitHub for me to access and use, and we call those things resources. So resources are collections of data or functionality. Basically, they are the things the API can touch, right? So in GitHub, that's things like users, repositories, commits. It's all of the different objects that make up the functionality of GitHub. If we were to go to a really fun example API, which is the Poke API, this is an example REST API for Pokemon data. We see a kind of similar thing. If I come here and look at this example, I've got the Pokemon API, and then I've got Pokemon. That's one of the things that we can access in this API. If I were to come to the documentation, you see I've got Pokemon, moves, that's a thing in Pokemon. I've got machines, that's a thing in Pokemon, items, locations. These are all categories of things that exist in Pokemon. And so they are all called out in the API. They are the resources that makes up this API. If I were to go and throw this into curl, just like I did with GitHub. So I do curl. Here I get a big blob of JSON data in much the same way as I did with GitHub. And if I scroll back up to the request, that was a really long request. This is very similarly structured, right? When I curled for GitHub, I had api.github.com/users/Joe Nash. This is /Pokemon/ditto. Do you see how that structure is similar? We have a resource, a collection of things, and then we have the thing we're asking for. And that is a really important thing about REST APIs, which, don't delete that whole thing, which is that resources represent the objects we can touch, and then we use HTTP methods to touch those objects, right? Does that make sense, folks? Do you see the commonality, the common pattern between what we did with GitHub and what we did with Pokemon? And that's exactly the same for Twilio. If you follow the Twilio challenges this week, you will make some API requests to Twilio, and the kind of objects, the resources that you will see in that API will be things like messages. There'll be voice calls, and those are represented by resources in the URL. So, the really interesting thing about that is that resources are exposed through the URL structure, right? So when we use the API, we know what we're doing by what's available in the URL. We know what objects we're touching by the URL. Now, a really interesting thing that you may or may not have noticed is that the URL describes what object we're touching, but it doesn't describe how we're touching it, right? So here I've got api.github.com/users/Joe Nash. I don't have I don't have something like get user/Joe Nash, right? I don't have like create user/Joe Nash. I don't have something that looks like a function name in the URL. And the reason for that is that REST relies on the HTTP methods to say what we're doing with this data. So we have a resource, but then it's the HTTP methods that tell the server how we are using that resource, right? And we've seen those methods before. So we looked at a bunch of those methods earlier, and we had methods for getting data with get. We had methods for creating data with post. And REST uses these methods as part of the kind of standard, as part of the way things communicate. So if I were to go to, for example, this URL with curl. Sorry, I don't know why I keep closing this terminal. No, I actually have to wait for it to restart again. So if I make a curl request and I use the X flag, that lets me specify what type of HTTP request I'm making. If I send a GET request to this URL, because I'm sending a GET request, the GitHub server understands that I'm asking for this data. I don't have to call an endpoint like getUser because I'm trying to access the users object for Joe Nash, and I'm sending, oh, hello, Windows Defender, thank you. and I'm sending a GET request to that API. So what else could I want to do other than get the data? What I'm asking to do with that data is obvious from the HTTP method. Whereas if I changed this to something like, for example, post, this would be, and I were to go to users, this would be the server is saying, hey, you're trying to go to the user's endpoint, which is where the user's resource, all of the users lives, and you're saying you're going to give me some data when you do that. Well, I can kind of guess as the server that the reason you're giving me data is because you want me to create a user. You want me to create something with that data at that endpoint. So again, I don't need something in the URL like create user, because the HTTP method is telling the server what it is that we're trying to do with the data at that point. Now, obviously, GitHub doesn't allow random people around the internet to create users using a HTTP request, so I can't actually do that because that would be unwise. But that's how GitHub applications work in the background, right? When you go and create a new user on GitHub, it could work like this. Akbal says you can also use Postman. Yep, so I'm using curl. I like curl on the command line, but you might have heard of Postman. Postman is a graphical HTTP client. It has the same functionality as curl, except it gives you a nice GUI interface for it. There's lots of other graphical HTTP clients. I really like Insomnia. Last time I was here, Rosendo posted a really good free one in the chat whose name I've forgotten, but there's another free HTTP, another free Postman alternative that's really cool. If he's watching, he might post it. Otherwise, we'll have to leave it to imagination. Hopscotch! Yay, he's watching. Thanks, Rosendo. Yeah. That is the important thing about HTTP methods, which is HTTP methods tell the server how we're using that resource. So what we end up with is a kind of rule book for using APIs that lets us guess what functionality is available. What functionality is available through the URL structure. So, but just by looking at the URLs for an API, we can guess what kind of objects we're able to use and manipulate, and then they let us actually make those requests to do that functionality just by HTTP requests. And using the HTTP methods to communicate what we want. Right? Does that make sense? Folks, give me thumbs. Give me thumbs and questions. Thumbs up if that's all good and you understand. What questions does that raise? Is there anything that's not completely clear? Whilst you're asking those questions, Koshik asks, what Linux terminal am I using in Windows? So that's a complicated question. This terminal, this application, this is Windows Terminal. This is a new terminal by Windows that is open source. You can find it on GitHub. However, I don't actually think that was your question, because you asked what Linux terminal am I using. So I think you're actually asking, like, what's providing the Linux functionality here? Well, for me, I use WSL2. That's the Windows subsystem for Linux, which basically installs a Linux virtual machine in your Windows and makes it accessible to lots of applications. So Windows Terminal can access the Ubuntu that's installed with WSL2, but it can also create PowerShell or command prompt or any other type of terminal in here. So I really like WSL2. If you use something like Git Bash or Cygwin, WSL2 has a lot of advantages. It's a little bit more complicated to set up, but it is really fantastic. And that's why I use Windows nowadays. Regular viewers will know that I usually use Mac, but I have changed to Windows because WSL2 is so good that I don't really need to use Mac anymore. Okay, so we haven't had any questions, so I'm going to assume that everyone is feeling good. So, last couple of things about HTTP and REST APIs is there's some stuff that we mentioned in HTTP requests that we haven't spoken about. So some of those things are for example, headers. So headers are where we put additional information that the server needs to handle our requests. So for example, if we go back to the GitHub API documentation, and we go to one of the endpoints, one of the pieces of API functionality that requires authentication, for example, get the authenticated user. So that's an API endpoint to get the user that's currently logged in. Well, how do you log into an API? You know, I'm calling GitHub in curl on my command line. How do I log in? Well, that's where headers come in. Headers allow us to send information to the server that it needs to handle our requests, and an example of that information is login information, authorization information. So over here, if we look at this little box here, we have an example curl request. Here's the URL. You've seen me using this so far, but we also have these things beginning with capital H, and that capital H is for header. They add a capital H adds a header on to the request, and one of those headers is authorization. So this is the header that contains the authorization information for me to log in as I use the API. And so this sends a little bit of extra information along with my HTTP request that tells the server, hey, this server wants to use a endpoint that requires authentication, and here is their authentication information. And you'll see here it's got a placeholder for token. You're probably used to username and password, where you put in a username and a password. A really common method of authentication for APIs is instead of having a username and password, you have a token. And a token is something that you'll generate on the website for that service. So for example, if you log into GitHub and you go to developer tools, you can generate a token. And that's kind of like your password for that API. So here the authorization is token, and I just put my token in, and that authenticates me to the API. There are other types of headers. For example, here you're seeing another one. The accept header lets the server know what type of data you will accept as a client. So when I go to a website on my browser tells the server, hey, I'm a browser, please give me HTML. I would like HTML. But when we're using an API, you know, we are happy to work with data. And so in this case, the accept header is telling GitHub that we want JSON. So those are some examples of headers. Sometimes headers are complicated and they contain some weird things. So for example, there are experimental features on GitHub. What would be an example of an experimental feature? Dependabot? Code scanning is probably an experimental feature. Nope. Do they not do this anymore? So there are some experimental features on GitHub, and the way they do that is they add a header to indicate that you're using a beta piece of software, but I can't find an example of it, so maybe they don't do that anymore. But sometimes there can just be random headers that have contain whatever data the person who runs the server wants you to use. Now, one thing we haven't spoken about is how you send the data in a post request. So we spoke about post requests being a HTTP method that allows you to send data. Let's take a look at an API that actually uses post requests. So this is creating a GitHub issue. If you haven't seen it, GitHub has a piece of functionality called issues where you can track tasks related to your projects. And you can, unlike a user, you can create an issue from the API. So what we're doing here is we're sending an API request, a HTTP request, that contains some data that will be used by GitHub to open a GitHub issue for us. Now, if we look at the example curl request, we'll see that it's a curl request that's using that X flag, which, as I mentioned earlier, allows us to change the HTTP method. So it's a post request. We've got the two headers that we've already spoken about. So we need to create an issue. We need to be logged in. So it sends an authorization header. And then it's got a D. Now, D is for data. It is to add some data to what is called the post body. So a post request has a body which contains the data that you're sending, and in curl you send that with a D, and because this is a JSON API, that data is sent as JSON. So we have a title, and then the title, we have a body for the content of the issue, and we have body, and all of the other parameters that we can send along with this data will be specified here in the documentation and can be added into this JSON object and put into the post body when we send it along. So it's really simple to send post requests and add things to the body. There are other ways of building up those bodies. You can actually specify kind of like property by property in many HTTP clients. For example, if you use Postman, there are options to just have like, you know, one big field for the post body, but then you can also add just individual properties. So you could specify the title as a field and add that in. And so any HTTP API that has a post, you can add your data in whichever format it wants, which will often be JSON, and send it over with the request. Okay, so I only have a couple more minutes. Let's do a brief summary and run through everything we've learned today. So we've spoken about what an API is. It is a way for you to access application functionality from your own applications without having to know the implementation details of that application. We spoke about that as the example with the restaurant and the waiter, where your interface to the restaurant is a menu and a waiter. You can sit down, have a look at the functionality available at the restaurant, and place your order with the waiter, who will go off to the kitchen, get that order made, and return the food to you. And you don't have to know what's happening in the kitchen or how it works. The important thing is you've got your menu, which is your interface, and the waiter, which is your API client. And then the server, the kitchen, can create that food and give it to you, and you don't have to know anything about what happened in between. APIs don't only exist in restaurants or in the internet. They can describe anything where a set of programmatic functionality is exposed to another program, and that includes the names of functions and variables and objects in libraries and our own program. If we were to import another library, the functions that library makes available to us are an example of an API. But in particular, we are really interested in web APIs. Web APIs make use of internet protocols like HTTP, the Hypertext Transfer Protocol, and an internet protocol is a set of rules for us to communicate between devices and clients and servers on the internet. HTTP lets us make HTTP requests, which have headers, methods, and go to a particular URL, and those requests are sent by clients and handled by servers, which send us back the information we ask for. The HTTP methods let us tell the server what action we want to do, ranging from getting data to creating data to deleting data and updating data, and that's captured in the request. So when the server gets that request, it knows exactly what we want. And these bits and pieces are used to build up the standard for APIs, which is the REST API, which provides a predictable, understandable way for us as human developers to understand how to use APIs in our programs, so that if we encounter any API on the internet that we want to use, we intuitively have an idea of how it works, thanks to resources, the collections of things that API lets us access, which are exposed in the URL, and the functionality available to us on those resources, which are exposed via the HTTP methods. So we can get user data by going to an API, hitting the user's resource and sending a GET request, or we can create data such as GitHub issues by going to the API, the issues resource, and sending a POST request. And although this is an interface for programmatic applications, a really important part about this is that it makes them predictable, so that if you encounter a REST API anywhere on the internet, you can go and look at the documentation, but you also kind of have a intuitive understanding of whether you can use it or not. And Kaushik has asked, are you familiar with Vonage? If yes, can you give a brief intro? I am familiar with Vonage. Vonage is a Twilio competitor, so I myself probably can't give a brief intro, but I would recommend checking them out. They do similar thing to Twilio. They expose communications APIs that you can use from your applications. They have pretty much all the same stuff, I think, as Twilio does. So, you can check it out and compare and choose whichever one you think is best suited for you. So that is all I have time for today. Just a reminder, you can access all of the tutorials for the Twilio challenges this week. So you can find all of the tutorials at this website, at this GitHub repository. This will walk you through all of the challenges, and you submit those challenges back to the Global Hack Week challenge page. If you need any help or you have any questions about completing the Twilio challenge, you can find me in the Global Hack Week Discord, in the Twilio channel. Thank you all so much for participating and answering questions in chat. I will see you in Discord. Bye, everyone.